All right, so here we have there we go. A company manufactures and sells X microprocessors per week. If the weekly cost and revenue equations are C of X, meaning the cost is equal to 5,000 plus 2X, the revenue is 10X minus X squared over 1,000, and it's between 0 and 8,000 is how many microprocessors we sell each week. Then we're going to use differentials to approximate the changes in revenue and profit if the production is increased from 6,000 to 6,010. So that would be kind of like X1 to X2, right? All right, so what do we need? Well, let's see. First off, we need profit because it's talking about profit. Well, profit is what? P of X is going to be equal to R of X, the revenue, minus our costs. So if we take this minus this, we'll have 10x minus 2x, so that's going to give us 8x. And we'll have, and then it looks like that minus that, so it's going to be a minus x squared over 1,000. And then it's going to be minus 5,000. Okay, so that's going to be our P of X. So that's a good start. What else do we need? So now let's see here. We need to find out what P prime of X is, I guess. So P prime of X is going to be what? Well, if we take that, that's a 1, bring that down, so that's just going to be an 8. And then it's going to be 1 minus 1 is 0, so x to the 0 is 1. Bring this down, so that's going to be a minus 2x over 1,000. 2 goes into 1,500, and so we'll have a minus x over 500. That's a constant derivative. That's going to be 0, and so that means this is just our derivative. That's all we have to have for our derivative, okay? All right, so now let's start looking at the differential. So we want to look like we need just a dr and a dp is really what we're looking for. So let's do dp first. Well, dp is going to be what? Well, that's going to be the derivative of p and then times dx. All right, well, then that means dp is equal to, well, we found this already, right? So that's going to be 8 minus x over 500 and then times dx. And so now what we need to do is it wants us to calculate it based on our changing here. Well, if we do the dx, that's going to be what? 6,010 minus 6,000. So that's going to be 10. So dx is 10. X1 is 6,000. So dp then is going to be 8 minus 6,000 divided by 500 times 10. And so dp is equal to, so if we plug that into our calculator, we get 8 minus 6,000 divided by 500 times 10. So that looks like it's a minus 40. And this is in dollars per week. So this is going to be a minus $40 per week. So our profit is going down by $40 per week when we increase production from 6,000 to 6,010. So that's not a good thing. Now we also want to look at revenue. So DR. Well, if this is R, what is going to be R prime or our derivative of that? Well, that derivative is going to be 10. That derivative is going to be a minus, and then 2 here, that's going to be x over oops, not 5,000, but 500. Too many zeros. So that would do that. So now we have that, and that's going to be our prime. So we're going to do exactly the same thing here, except now we have dr is equal to what? Well, r prime of x dx. So dr is equal to 10 minus x over 500 times dx. And we've got all the same things. We've got our dx we need. We have our 6,000, so we just plug it in. So dr is equal to 10 minus 6,000 over 500 times 10. And if we change that from an 8 to a 10 now, then we get the following. We get negative 20. All right, so DR then is going to be negative $20 per week. So that means our revenue is going to decrease by $20 per week, and our profit is going to decrease by $40 per week. So in either case, it doesn't look good. And so what I'm thinking is we must be, if it's, say it's a parabola over here, it's good, but we're now down here on this side and our profits and revenues are going down instead of going up like they were on this side. Our slopes are negative. So that's the problem in this case. So that's all I have for this section. So hopefully that will help you get through that.